This particular example is a classic geometry meets algebra problem that we see in pre-calculus and even into calculus classes. And sometimes I find part of the issue is actually visualizing what's happening when we cut out these corners to make the box. And I have this another image here that maybe can help you can kind of see where if we cut out these equally sized squares on the corners of either a square piece of paper or a rectangular piece of paper, then we can fold those other parts, those other ends up and form this open box. So I just wanted to show that, kind of help give some more of an illustration to what's really happening. So with that being said, I know that we're going to find volume eventually. And for volume of a box, I know that the volume is length times width times height. So I'm going to need a length, width, and height of this box. Well, the height actually turns out to be x, the size of these little smaller squares cut out from the corners. So that would be like this little segment right here. That's going to be x. What I also need now is what's on the bottom face of this box. In other words, these dimensions here. And to find those dimensions, if I use the paper in its entirety, which was 42 inches, and I subtract these little segments, x and x, or in other words, 2x, I get that the length of that side is 42 minus 2x. And because this entire thing is a square, I get the same thing for the length of the other size or dimension on the face of that, the bottom face of that box. So at that point, that tells me both the length and the width are 42 minus 2x. Placed all together, I'd multiply 42 times minus 2x times itself times x, and that's how I got this volume formula over here. So I could have rearranged that a little bit. Like I could have placed x in the front. I could have multiplied that out, that binomial squared out, but it accepted this in my math lab, so I went with it. Now, the next couple of questions ask for specific measures of x, so I can just simply substitute in 8, and I get this output. I can substitute in 20 for x, and I get this output. And then after that, I need a graph. So I turn to Desmos just to get a sense of the graph. Also looking at the scale, make sure that you mind the scale there, that you either zoom out or set the scale as such. And then I can quickly see what the maximum is, again, using Desmos, that the maximum value occurs at x equals 7.